Welcome to Openshift Kubernetes demo part 3. In this video we are going to see how we are going to deploy our own images which is built by Openshift Build Manager, and how we are going to scale up, scale down, and after that we are going to see how we can benchmark the uh, pod to get the numbers of number of pods, how many number of pods we need to meet our demanded request. First let's see, um, so we already seen these slides, and we have created one Docker repository which is running in 1.37.0.5001, and also we have pushed our build manager as a pod in the repository as a custom pod, and also I have walked through a schema of how we have created that Docker repository and all. Now I am going to walk through the schema for applications. Like uh, if you go and see, so I have created the, our own UI for OpenShift cluster manager in action. So you can see in action, so as of now only one pod is running in that OpenShift cluster, so that is called registry pod. This pod is going to act as a private owned registry for our OpenShift containers. You can call this a OpenShift gears. So now we are going to deploy uh, deploy some of the real Node.js Mongo applications into that open cluster, and we will get reflect in this UI itself. So now I am going to demonstrate. Okay, let's take this one. So I am going to open the folder. I think it's already open. Okay, the folder is already open. So now I'm going to create the templates for pushing my images to the repository. So we already seen that. So we already have created the Docker images by that OpenShift Build Manager. So you can see that is running as 127.041 this demo, which we created before our. So I am copying this image name Tesco OpenShift demo, and I am going to open this template file called node template.json. So here I am explaining ID called node mongo test OpenShift template, and the name is called node.js mongo test OpenShift template. This sample shows how to create a simple node application in OpenShift version v3. So, and here I am creating a load balancer, that is the services for our pods, which is equivalent to what we created in last series of Kubernetes. So same thing, like, so I am putting that service name called node service, and then the container load balance is going to run on 7000 port, and the selector label is the label which we are giving here. So I will explain now. And now come to the last part, that is called replication controller. I am asking to push five Node.js Mongo application which we just now we created. I am just copying pasting to the newly created images called Nenbob Sundaram Tesco OpenShift demo, and the container port is 7000, and this address I am giving here. Then that's what the same address giving in a selector in the load balancer service. Then if you see the middle part, that is called deployment part. I already said whenever you deploy something into that OpenShift private registry, you should have that kube deploy module, which will do the orchestration layer, which will take the request and deploy things into that private repository. That's what this things is doing it. So we have three parts. One is load balancer, another is replication controller, which is going to deploy 5 images of the newly created image as a container, and is going to run in 7000 port. So, and also the service also return port, and it's controlled by this guy. It's called OpenShift Cube Deploy. That is the image given by the OpenShift team. So now we have the template name. I'm going to use this template. So I saved it. So I'm going to use this template to build this images. So I am taking this script. So this script will, what it will do, I'm just creating this, apply this, apply this node template. This is the command. Okay, copy this and go to execute it. Clear. I'm going to shift it. So node template, which is just we updated, and then we got one template. So that template is a compiled template JSON file. You can see here it is going to utilize that new image which is just now we created. Okay, now I am going to deploy the parts using the second command, which is called cube apply. The same. So control V. Okay, for clear purpose I will. Okay, OpenShift cube process. I am using the node template JSON, and as well as I am using that OpenShift cube apply. Apply means whatever the configuration which just now we applied in the memory, it is going to apply the same thing. So I'm going to apply that. So we got that two status image, and also there are some reflection is coming over here, and there are something is going on the Docker side. So now you can see that creation succeeded for service. So our load balance service are created. It's called node load. Named load balancer called node services created, and also it is pushed for the deployment for the node services. So now I am going to see that how many parts which is so just now we deployed 5 parts. Let's see in UI whether it is anything is reflected over here. I'm just refreshing it. Nothing. Oh, awesome. So we got that all the parts which is running as a address thing. You can see that address 1, address 2, 3 and 4 and 5. So OpenShift awesomely orchestrated the request which just now we given, and also it is deployed the parts in a second, and it is running that our newly created images over here. So now I am going to test this part by giving the command. That's it. So far this is my address which is running in 7000 port. I'm going to just hit it 7000. So we are able to get the we are able to. So now it is talking to the MongoDB, which is this container is running in an OpenShift cluster, and it is talking to the external world which is hosted in outside the cloud, so MongoDB, and fetching the result based on that based on this postal code. So that is excellently it is working. So same thing you can see that is the really it is things you can see using OpenShift cube list parts. So now you are able to see that all the images which is created by OpenShift. So you can see the running. So this is, see here, this is called node mongo's take OpenShift running. So this is also a running, and this is a Docker. That's what we are seeing. We are seeing the same thing in that in the UI. So except this registry part, all are addresses. Is it? So all the files are addresses, one registry parts. Now I'm going to ask, hey, can I resize? Can I scale down how many? So as of now, initially I deployed 5. Now I want to quickly I want to scale down and scale up. So let's see in action. So for that, so I'm going to use that. So I'm going to first this down with OpenShift. First clear this one. You can get the more spaces. So cube list replication controllers, is it? Yeah, so there is a replication controllers running for this part. So I'm just copying this name of the sorry, let's put little big screen. So again I'll run it. So there you go, this is easy to copy this. Okay, so I'm copying this, the name of the now I'm clearing it. Now I'm going to scale down to from 5 to 3, then I will scale up as I need it. So for that, Openshift cube resize, controller name to 3. So I'm going to scale down from 5 to 3. So now I got it. So here you can see that. So current state is 5, but I am asking to deploy to desired status to 3. So now you can see that. Let's put it. Okay, so desired state to 3, but current state is 5. Now in this second, so it must be downgraded to from 5 to 3. See that in action. Awesome. See, all first 2 and then these are 3. So all things are in a minute. You can scale up and scale down as much you want. So that's the beauty of this Kubernetes, and now it is powered with Kubernetes cluster. So now I'm going to again back. Is it? So clear. So I'm going to back. Okay, as of now it's 3. So I'm going to say, okay, can you deploy to 7? Is it? So I previously it was 5, now it is 3. I am going to say it is 7. Okay, so now it's done. So let's see how much fast it can deploy the images as quickly. Okay, now that 5 is running. Oh, now it's awesome, is it? So now all things are, so all the 7 are our newly created pod, and the beauty thing is everything is in running status in a minute. So now you are able to scale up and scale down in a second using Openshift cluster manager, which I am demonstrating now. So it is excellent in action. So I hope that Openshift v3 definitely is in production condition, but it has to be officially announced from the Openshift team. Okay, so now I am going to show that little bit about the performance. How is it leveraging that performance for the Openshift? Okay, so now I am clearing it. Now I am going to run some benchmark testing for the same addresses. Is it? So I already shown there is the address localhost. Sorry, just now. Okay, this is the guy. Is it? This is the guy. So I'm going to ask. Give the 5 address for my, okay, so for my test bench purpose. Control C. So I have that bench test tool, that is actually simulation for the load test. So what it can do it, so we can specify how many number of iterations can run and how many concurrency of request you need to put it. So that means a 50 user can press at the same time, or 100 user can press request the same request same time. That's what it is going to simulate that. So now I am going to do that bench test, and the URL I putting, then I am putting -n, that is equal to number of iteration. I am going to put it 100. I am going to put it concurrency is 50. So 50 it is running that 100 iterations in a concurrency mode. So now you can see in action how much it is robust. So that's it. So in a second, all the 100 requests came in a second, even if it's not a microsecond. So you can see the histogram in very variable manner. So now I am going to run that little bit large request. So I am going to put it 1000 requests and the 100 concurrency. still it is good. 1000 request is completed in a second, is it? So now I'm going to put it. So can we put it 200 persons are doing that 1000 request. Okay, first clear it so you can see that. Okay, same thing. So now 1000 requests will be served by 200 persons. Awesome, it's very much fast. You can see that all the requests, and he in left hand side and the top side is receiving request. Now I am just increasing to 10,000 with the same concurrency of 200. How it is doing it? Okay, still it is able to handle 10,000 concurrency in a very quick time. So now I am going to tell that, okay, can I increase it to 1 lakh records, whether it is able to spawn. That means it's a very huge request. Let's see, I'm expecting some of the error, or so may it can withstand the load. Still it is surviving without any error. Let's see, it is 100,000 records or requests are going with the 200 numbers concurrency. See, in such a simple system, which is it is running in my laptop and having a 7 containers, and it is able to scale up to the 100,000 requests without any error until now. So I'm thinking there may be errors, but still it is able to so it definitely it can work excellently in um, uh, production system, like such a big hardware or something like network bandwidths. Say here I am just running in a small small um, network modem, and it is running in my machine with a hardware. Even my system have little bit more other services also running, so definitely it can scale. So as per the conclusion, I hope definitely it will work in a production environment in very well manner. And also the provision which is provided by this easily scale up scale down in a second, it will give that more confident. It is giving more confident for us. So you can meet any number of scaling request scaling, and then you can achieve whatever you wanted. So that's what I can conclude it now. Let's see that. So you can see that it is zero error. This is your histogram. So it's excellent in things. Still, since my entire clusters in my machines, so you can still it is working excellently. So definitely, if you put in a real cluster, it will work beautifully with the number of nodes. It's here. It is only one node with the 7 containers. Right. So now, can I break that? So I can break it, because that open clusters having that configuration like more like limitations. Okay, let's see. I'm going to put it like so 300 concurrency. That means it's very huge request, or 1000 concurrency. Sorry, 10,000 request in 1000 concurrency. Very huge request. I don't think so. It can withstand with the concurrency. So here you can see that error and also in right hand side it's telling it open too many open files. You can see that here too many open files is in that Openshift. Is it? So still after 10,000 calls, 3,423 calls are got error, but other things are served quickly. So if it is a robust thing, it can serve like anything. I can see. Is it? So that's what my theory is all about. And so come to that conclusions of so I'm just going back to this things. So we are able to deploy parts using replication controller, which is provided by Openshift, and we are able to create the name load balancers. And I can say I showed already. And then so I already shown it how we can how we can do scaling in robust manner, scale up, scale down in a second. And then how to control pod services application control using OpenShift Kubernetes REST API. So I'm going to show it little bit comments about it. So you can do via like OpenShift using kube REST commands. So here kube list services, you can do create, update or delete anything which is using this one. So it is a REST services. So they are giving. So if I hit only cube, you can see the number of like help system which you can show this. See, they are supporting it. Get, list, create, delete, update, and all things. So you can specify build configuration, you can share builds, you can show the configurations or deployment configurations and deployments, image repository, image reports, mappings, image, minions, pods, projects, replication controller, routes and services. So everything in your place. So using this, you can achieve anything. So list or create or so you can I'm doing listing of minions. So as I told already, only my machine is working as a minion, so you can connect as many minions you want. So and also like how many parts are running, how many things are running, you can call it. That's what you are able to see in that UI. And then how many services you are running, services. So you can see that there is a one service is running in 5001 for registration of part, and another service is running at 7000. That is a name load balancer for our Node.js Mongo Tesco OpenShift image. Okay. So and how many replication controller is running? So you can see that. So you can see that one the replication you can run the replication control for this and as well as if you want to as many parts you want to for that registry private Docker repository, that also you can control via this replicas. So already they are running, so you can have that as many parts for your own repository. So all the things you have that everything in a hand. So so we are able to scale up, scale down and everything, and as well as that Docker PS I am running, how many images are running. These are the images which is running. So these are the two Kubernetes Pasco, that is nothing but actually a kubelet service which is running. This is our own image, which is N Babu Sundaram. Latest it is running with this particular ID. Okay. So for example, I'm going to show in some self-healing in action. Suppose, is it possible, like if something happened to my container, really is it taken care by automatically? So for example, I'm going to kill some of the container which isn't running. So you can see that this guy is running now. As of now, I'm going to kill, for example, anything. Okay. Okay, so I'm copying this going to kill that. In front of you, docker kill this id. So it's killed. Is it 6fcd? So one of the containers which is running, it's killed. So now you see it. So in a second, it is spawn the another container which is address. There is no matter you want. If you kill, so automatically the image will be spinned up for you. Okay. So now you see that instead of this one, okay, there is another images which is created automatically once you killed. You can see that it is created, just created 7 seconds ago, because you killed one thing, so it's automatically gotten by the Kubernetes system. That's the power of the Kubernetes system. If you kill, or it's automatic killed, or anything, power shortage, or anything, if you something it's happened via because of the throttling, or something is killed by denial of services, automatically your system will be automatically healed up. It is auto healing is in place, self healing in place. You don't require to worry about it. Hey, I told to run 7 containers, but some reason something is get killed, but you don't require to worry about it. Kubernetes is automatically taken care, and it's created the image for you within a second. You can see that it is created, just created after killing it. Even you cannot see the changes. So for example, I am going to do the same thing. So 4b 22a 3b cd 586, I am just copying it. I am going to kill it again. Okay, clear. So docker kill. So I killed that. See that, go and see that. Is there anything you will feel as a difference? But there are some IDs changed. See that, go and see docker ps again. Somewhere it is created, wait. Okay. See that? It's been a new machine called before 3 seconds. You got it? So even it is not waiting for a seconds to up the another machine. So it is created another machines on the fly. Sorry. I think we are seeing some other things. Docker PS. Confused because of the huge images. Okay, I think better we can kill some other thing. Okay, so here there is our images running, is it? In Baba Sundaram Tesco Openshift latest. So I'm going to kill one thing. This one 61 FD1 15 C75 C56. Is it? Okay. So docker kill, enter. It's killed. So but are you seeing anything? Oh, see, one down. But how many things we asked to run? 1 2 3 4 5 6 only. Okay, see that? So now you are able to see one guy came up automatically without I didn't anything I did doing it. So automatically it's one guy came up within a 1 or 2 seconds. Even it is not even seconds. So like again I see that, is it true? Yes, in the UI is doing something. So you can see the status. So you can see that. So one guy is up before 26 seconds. This guy is up 2 minutes because it's our play. So this way you can do it. I am not able to see that which is the newly created. But so you are able to see in the things. If you kill it in the UI, you can easily see that. So which one is come up? Is it? So as many you kill, quickly you kill that. So you can kill anything which is even 20. So it's up before 20 minutes. So I just killing this one. Control Shift C. Docker kill. Quickly go up. Go to this guy. One should be down now. I think it's up. So even you are not able to see that flickering speed. So your all containers are running without any problem. So automatically it is served, it is self-healed automatically. There is no one down. So that's the beauty. So you can, even you are not able to see that changes. So this is the self-healing in action. So we already covered all things whatever we needed. So, and also I have covered benchmarking using bench rest. That's all for my demo. I hope you enjoyed. So so Kubernetes is helping us to self-heal. Kubernetes is helping us to orchestrate and scale up, scale down in a second. And Kubernetes is helping us to work with any of the vendor like Openshift or Google Cloud, or you can name it. If there are some big list in Openshift in Google Kubernetes, so everything is possible with Kubernetes. And then now that you can put more monitoring on top of it, it will be very robust. And I already shown in previous videos how the C advisor is working, how to monitor the health of the system. Everything you can do it. Even many of the vendors are creating health monitoring systems top of the containers. So you will enjoy in every features of Kubernetes. Okay, thanks for the opportunity for giving that. And if you need any help or comments, you can fire the email ID nbabu.sundaram@gmail.com. Thank you. All the best.